All the circuits that we have looked until now, they are known as combinational circuits. So basically, you had a set of inputs and you had a set of outputs. So whenever the inputs were changing, you were noticing a change in the outputs, right? So the output only depends on the current value of inputs. So using combinational logic, you can create circuits such as encoders, decoders, multiplexers. However, most practical designs, they are sequential. So these are combinational. And next we have sequential. So in a sequential circuit, it's going to look similar to your combinational circuits. So you have the combinational circuit here. You have inputs. You have outputs. But the thing with sequential circuits is you have a feedback. So this is the feedback part. So your output not only depends on your current value of inputs, but it also depends on the past sequence of inputs. Whenever we talk about past has to be stored somewhere, right? How can you recollect things from the past if you do not have it stored? So this is where the concept of memory comes in. So a sequential circuit is going to have inputs followed by some combinational logic followed by outputs and followed by memory. The current value in memory is known as the present state, and how the memory gets updated is given by the next state. So the next state, it depends on present state and input. Again, just to reiterate, in a combinational circuit, the output depends purely on the current input. In a sequential circuit, the output depends not only on the current inputs, but also the past sequence of inputs. This past sequence of inputs, they are stored in memory. This is where the concept of memory comes in. The memory has two states, the present state and the next state. The present state is nothing but the current value in memory, and the next state depicts how the memory is going to be modified. So your next state depends on the present state and the current input. The two most common memory elements are latches and flip-flops. Both these components have one or more inputs and two outputs typically. First output is Q, and the second output is the complement of Q, which is Q prime. Latches are asynchronous elements or asynchronous memory components. Flip-flops are synchronous memory components. We are going to talk about asynchronous and synchronous in the next few classes. So in both latches and flip-flops, inputs have the capability to change the state of the memory. Change state.